All right, hello Math 10. We are going to be taking a look at making factor trees. This is something you've done before, I know, but sometimes you forget how to do it. And also it's going to be important because we are looking at greatest common factors and lowest common multiples. And to do those things, you're going to need to know how to do a factor tree. And remember, all the stuff about factoring numbers, like that's not really the juicy part of Math 10. This is really just a metaphor for when we start doing factoring with polynomials. That's going to be like the juicy thing. So really this is sort of like practice for getting ready for that. It's also good though. I mean, we also have to find GCF and LCM too. So it's not a waste of time. But remember, it's not like the big thing. But we'll take a look at some examples. So factor trees are basically ways to show how the prime factors of a number. And prime factors are actually pretty interesting. If you break down a number into its prime factors, it's almost like looking at the DNA of a number, kind of looking at how it's constructed, and then you can compare that DNA to another number's DNA to sort of find patterns. That's why we use it for GCF and LCM, because we can kind of get a better insight into the number. And that's true about polynomials eventually too. That's why we factor polynomials, to get better insight into those types of things. So let's take an example. Let's take a look at doing a factor tree for the number 24. So again, you've probably seen this, so I won't spend too much time on it, but don't hesitate to ask for more examples in Teams if you feel like this wasn't clear enough. But basically, we're going to start. I'm going to use getting out the pen. This will be exciting. So we're going to do 24, and you just start dividing it into numbers. There's no like specific number you should choose. Just find a number that divides into 24 and get started. So for example, you could start with 2 and 12. You could start with 4 and 6, whatever you think is good. So what do you think? I'm going to go with 4 and 6. Oh, still got to work on my math teacher writing here. So 4 and 6. So 4 and 6 are factors of 24. We talked about factors in the last video. They multiply to give you 24. But they're not prime numbers, right? They're composite numbers. So we got to keep digging, go further. So 4 breaks down to 2 times 2. Ooh, look at those numbers. I'm getting it. I'm getting there. Oh, I ruined it. So 6 is going to break it down into 3 and 2, right? Or 2 and 3, I'll say. And hey, look at that. We've got to all prime numbers. Once your branches end in prime numbers, you're done. You can't really factor the prime numbers. They just have the 2 factors. That's what makes them prime. So that's where we'll stop right there. So now you sort of have the DNA of the number. And you don't just like leave it as a factor tree. A factor tree is a nice diagram to sort of understand how you got there, but usually people write that out as like the prime factorization. You kind of look at it as a product. So you usually write this as like 24 equals, and then you write down sort of like all these numbers. You could say like it equals 2 times 2 times 2 times 3. That would be valid, but rarely do people write that because mathematicians like are lazy in like a smart way, not like a bad way. So they're not going to write all those 2's. They're going to write 2 to the power of 3. So a better way to write this, I don't know if I should go to the end. You could also write it as, instead of 3 2's, you could write 2 to the power of 3 times 3. And that's what we want to see. That's sort of what we're looking for. So factor trees are a pretty fantastic tool, actually, for doing this GCF and lowest common multiple. So I'm going to stop there because that factor tree concept, you might want to come back and watch that video later on just on its own without looking at GCF. So I'll kind of leave that here. In the next video, I'm going to show you how you can use factor trees to find the greatest common factor. And what's the other one? Oh yeah, least common multiple. We'll find the least common multiple. Maybe we'll do this in 2 separate videos. All right, thanks Math 10. I hope this is making sense. Ask lots of questions if it's not, okay? Thank you.